Okay, so version 4, question 3. This is a trig question, so check your calculator is in degrees and not in radians. Because if you're still in radians from calculus, it is not going to work. Or from comprehension. So, we model the fraction of the moon visible. So, fraction of the moon is f, starting on the 1st of January. T is the number of days after the 1st of January. So, if we put this equation into our calculator, we're being asked about the impact of the -10. So, if we put it in first without the -10, we've got a graph that starts at the top, goes down and cycles 3. If we go back in and put in the -10, then what happens is our maximum value is now at x is 10. So the impact, or what that -10 does, is it's a translation. So it's a translation of 10, 0. And so this means the full moon is on day 10, because a cos curve will always start at the maximum and then have its translations. So the full moon is on day 10, comma, and day 10 is the 11th of January. Okay, so what fraction is the moon being measured in? So if we look at calculator, then y goes up to 100. We know that it's a fraction, so it's going to be being measured as a percentage. So fraction of the moon goal. So what you may remember from the previous ones is they've either been written as a decimal or as a fraction. We're told that it's a fraction of the moon, so if we've got that 50 there, that's telling us that it's being measured as a percentage. So part C, a new moon. A new moon is when there is nothing visible. So a new moon is when f equals 0. So if we substitute that into our equation, realistically this is pretty much just to show that you know where it goes. T take 10. 50. So if we look, we've got G sub min. We could also look it up as when 0. So when y equals 0, x, or in our case t, equals 24.75. 24 days after the 1st will be the 25th of January. Okay, so state the period of a lunar cycle. If something says state, this means there shouldn't be too much working out with it. So for part D, the lunar cycle is 360 divided by your frequency. So 360 divided by 360 over 29.5. So the period is 29.5. This is actually accurate for our moon. So when you're looking at a period in the exam, you should be expecting something around either 29, 29.5 or 30, depending on whether they've rounded it up, down or what. Okay, so part E. We have noticed that there are werewolf attacks at the full moon, so on what day or days do the hospital staff need to deal with this? So full moon will be when the moon is at its maximum. So if we go G solve max, that is on day 10, which you might have remembered from part A. So that is when F equals 1, which is T equals 10, which is the 11th of Jan. Okay, so part F, complete and plot the table for January. So we've got 0, 5, 10, 15, 20, 25, 30. This is going up as a percentage this time. So we've got 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So we need to make sure that we've got our maximum on, our minimum on, and where it crosses halfway. So if we go into table, and we want our table to go from 0 to 30 going up in 5s. So we have 23.5, 74.2, 100, 74.2, 23.5, 0.07 and 28.1. Okay, so if we quickly head back into our graph, then we've got the minimum, and that happens at 24.75, so that'll be about there. And if we also take it xcal when y is 50, then we've got it at 2.6, which will be about there, 17.3, which will be about there, and 32, which is past it, so that's fine, we don't need to worry about that one. So plotting our points, we've got 0 and 23.5, so about there. 5 is at 74.2, 10 is at 100, 15 is also at 74.2, 20 is at 23, that is at tiny bit above 0, and 30 is at 28.1. So, key things that are important with this one, you need to not do straight up and down. That's referred to as a sawtooth. They don't like that. You need to make sure that you've got a nice curve going through, which will help if we don't hit another piece of paper. What you'll find is it's a lot easier to draw curves that way than it is that way, just because of the way your wrist bends naturally. So we end up with a nice cos curve, sine curve type thing. So we are asked for the gradient. Once we've done that, we are asked for the gradient on the 11th of January. So that is when t equals 10. And we're also asked when t equals 14. So when t equals 10, that is our maximum point, so our gradient will be 0. So f2 when n, not n, when t equals 10, because that will be the 11th, gradient equals 0. And then for part 3, we need when t equals 14. Now, if you have your calculator set up so that it shows you the differential as well, if you go into table, then if you put in x is 10 for the first one, it gives you the gradient of 0. If you put in 14 for the second one, it gives you a gradient of minus 8.014. Now, you cannot just write that down. So 8.014. You can't just write that down as is, you actually need to calculate it as well. So when t is 14, you need to plot that on your graph. So t is 14 will be 2 boxes there. So you need to draw a tangent at that point. So we then need to choose 2 points on your graph, ideally nice and far away from each other. I would probably go for the point itself and I would probably go for when x is 25. So when x is 25, here you've got a point 25, 5, and then if we pick another point up here, if we take that one, then we've got a point at 11.500. So we've got our 2 points on our line. When we do the equation for the gradient, we should have m equals y2 minus y1 over x2 minus x1. So there we go, 5 minus 100 over 25 minus 11.5. and that gives us an answer of minus 7.04, which isn't that far out of the minus 8.01 that we were expecting from the calculator. So that gives us the gradient when t equals 14. And then lastly, we are asked to state the transformations needed to move cos t. So we have that one there, which is times something. So that'll be a stretch scale factor in y. And we have something in here with our x value, which is also multiplied. So that will be another stretch. So we have a stretch scale factor 50 parallel to the y-axis, and from this bit here we have a stretch scale factor. Now whatever is in with the x, you do the opposite, so it will be 29.5 over 360, and that's parallel to the x-axis.